That's Further Maths Paper 1, June 2018. Mobile phones are not allowed in the examination room. This exams is 1.5 hours, that is 90 minutes. You are required to answer 50 questions and you have 4 different answers to choose the correct one by bolding the letter of the correct answer with an HB pencil like this. At the end of the examination, the invigilator shall collect the answer sheet first and then the question booklet. Do not attempt to leave the examination hall with these items. You're supposed to answer 50 questions in 90 minutes. That means one question is 90 divided by 50, which is approximately 2 minutes. That means you are not supposed to spend more than 2 minutes in one question. So the idea here is that if you cannot be able to answer a question in 1 minute, just abandon the question and go to the next. And try to answer the question that you are familiar with as fast as possible so that you can have more time come and spend on questions that you don't have an idea on. At the end of the examination, don't allow any question blank. Try to choose any letter for any question that you can't figure the answer rather than leaving it blank, because luck also counts. Number 1. Which one of the following is the eccentricity of a hyperbola? You know a hyperbola is the only conic section with eccentricity E greater than 1. Other conic sections like parabolas have eccentricity equals to 1. From the options, root 2 is approximately 1.4, which is greater than 1. So it means the eccentricity of the hyperbola is this one. That is option C is the correct answer. Number 2. The function f of x is equals to x plus 3 times x plus 1 all over x plus 3 into x minus 1 into x plus 2 has a removable discontinuity at x equals to a minus 3, b minus 2, c minus 1, d 1. A function has a removable discontinuity at a point, say x equals to c, if the limit of f of x as x tends to c is not equals to f of c. Let's find out for option A, that's minus 3. F of minus 3 is equals to minus 3 plus 3 into minus 3 plus 1 all over minus 3 plus 3 into minus 3 plus 1 into minus 3 plus 2. Minus 3 plus 3 is 0. 0 times this bracket is 0. Minus 3 plus 3 is 0 in the denominator. 0 times all this bracket is 0. It means f of minus 3 is equals to undefined. Now let us find lim f of x as x tends to minus 3. That is the same like lim x plus 3 into x plus 1 all over x plus 3 x minus 1 into x plus 2 as x tends to minus 3. You know, the first step to get the limit of a function is to simplify the function. This function can be simplified. That is x plus 3 can cancel x plus 3 and we'll have lim x plus 1 over x minus 1 into x plus 2 as x tends to minus 3. That is, to get the limit of this function, we are going to substitute the value of minus 3 anywhere that we see x. That is minus 3 plus 1 all over minus 3 minus 1 into minus 3 plus 2. Minus 3 plus 1 is minus 2. Minus 3 minus 1 is minus 4 times minus 3 plus 2 is minus 1, which is equals to minus 2 over minus 4 times minus 1 is 4, which is the same like minus half. That is 2 here 1, 2 here 2 times minus times 1 minus 1 all over 2. But we obtain f of minus 3 as undefined. But limit of f of x as x tends to minus 3 is minus half. That is lim f of x as x tends to minus 3 is equals to negative half, which is not equals to infinity, which was f of minus 3. That means lim f of x as x tends to minus 3 is not equals to f of minus 3. Therefore, the function f of x has a removable discontinuity at minus 3. So the right answer here is A. Number 3. If sin x is equals to 3, then x is a, b, c, or d. Sin x is equals to 3. It means x is equals to sin inverse of 3. You know, sin inverse of x can be expressed in the form ln x plus root x squared plus 1. That means sin inverse of 3 is equals to ln 3 plus root 3 squared plus 1. That's in the place of x, I put 3. That means sin inverse of 3 is equals to ln of 3 plus square root of 10, because under the square root sign we had 3 squared plus 1, and 3 squared is 9 plus 1 is equals to 10. That is why I have 10 here. From the options, the right answer is this, which is C. Number 4. The series summation un is convergent if which of the following is true? You know, the convergence of a series can be tested using the ratio test, and from the ratio test, a series un is convergent if lim un plus 1 all over un is less than 1 as n turns to infinity. So the right answer is this, which is C. Number 5. If z is equals to cos pi on 6 plus I sin pi on 6, then mark z minus 1 on z is equals to what? You know, if we have a complex number, z to the n is equals to cos n theta plus I sin n theta, then the identity z to the n minus 1 over z to the n is equals to 2I sin n theta. But you know, for this complex number, the power of z here is 1. So it means n is equals to 1. That is z to the 1 minus 1 on z to the 1 is equals to 2I sin 1 theta. Z to the 1 is the same like z minus 1 on z is equals to 2I sin theta, since 1 times theta is theta. So it means mark z minus 1 on z is equals to the magnitude of 2I sin theta. You know, for this question, theta is pi on 6. That means this is equals to the magnitude of 2I sin pi on 6. Pi on 6 is 30 degrees, the same like magnitude of 2I sin 30 degrees. Sin 30 degrees is half. That means the mark of 2I times half. 2I times half means 2 cancels 2 here, so be left with I times 1, which is the same like the magnitude of I. You know, mark I is equals to 1, because if we have a complex number like say z is equals to x plus iy, mark z is equals to the square root of x squared plus y squared. X squared is the real part squared, and y squared is the coefficient of I, which is the imaginary part squared. So for this case, mark I will be equals to the square root of 0 squared, since the real part is 0, plus the coefficient of the imaginary part, which is 1 squared, which is equals to 0 plus 1, which is same like square root of 1, which is equals to 1. That's why mark I is 1. So from here, the right answer is this one, which is D. Number 6. X all over x squared minus 1 into x plus 1 can be expressed in partial fractions where P, Q, and R are constant as A, B, C, or D. Let's find out. You know, if we have a partial fraction in the form f of x all over ax plus b into cx plus d, we can express it as a over ax plus b over cx plus d. This is partial fraction with linear factors in the denominator. You know, if we have a partial fraction of the form g of x all over ax plus b, the n, we can express it in the form a over ax plus b over ax plus b squared plus up to plus c over ax plus b to the n. This is called partial fraction with repeated linear denominators. You know, this denominator can be simplified as x all over x minus 1 into x plus 1 all squared. You know, x squared minus 1 is the same like x squared minus 1 all squared. X squared minus 1 all squared is a difference of two squares, which can be written as x minus 1 x plus 1. You know, the formula of a difference of two square is a squared minus b squared is the same like a minus b into a plus b. Now you see that x squared minus 1 times x plus 1 is the same like x minus 1 into x plus 1 times x plus 1. X plus 1 times x plus 1 is x plus 1 squared, giving this. Since this one is equals to this one, it means that we can express this fraction in partial fractions using these two formulas. That is x all over x minus 1 into x plus 1 squared is the same like a over x minus 1 plus b over x plus 1. That's this part is the repeated linear factor. That is, from this formula now I'll have b over x plus 1 plus c over x plus 1 all squared. So I'll continue to write the factors until I reach the highest power. X minus 1 can still be written correctly without the bracket. Now if I replace my letters here, that's a, b and c, with let's say p, q and r, we'll see that the right answer here is this one, which is a. Number 7, the integral of x all over root x squared plus 4 dx is equals to a, b, c or d. This integral can be solved by the method of substitution, because we see that if we differentiate the denominator, we'll have an x in the denominator that is going to cancel the x at the numerator. If you observe an integral, you see that if you differentiate the denominator and the numerator will not be cancelled out, so it means the method of substitution cannot be used. Let u equals to x squared plus 4. It means du dx is equals to 2x plus 0, which is 2x, since 4 is a constant and the differentiation of the constant is 0. That means du is equals to 2x dx. We divide both sides by 2x. That is du all over 2x. This all over 2x. The 2x cancel. Be left with dx is equals to du all over 2x. That means the integral of x all over root x squared plus u dx is the same as the integral of x over root u, since u was equals to x squared plus 4, and then the x now will be this one, that is du all over 2x. And observing clearly, you see x cancel x here. I'm going to be left with the integral of 1 all over root u times half du. So from the properties of integration, I can factorize out the half, which is the same like half integral of 1 over root u du. The integral of 1 over root u is the same like the integral of u to the minus half du. Since 1 over root u is the same like 1 over u to the half, which is the same like u to the minus half from indices, which says 1 over a to the n is the same like a to the minus n. The integration of a function x to the n dx is the same like x to the n plus 1 all over n plus 1 plus the constant of integration. So here we have the function u to the minus half. So it's the same like u to the minus half plus 1 as the formula all over minus half plus 1 plus the constant of integration. That means this equals to u to the half all over half. There was the half out here. It means this is also the half here times the half. It means I have also half times the half here. This is the same like u to the half plus k. Since this half is at the numerator, you cancel with this other half, 1 here, 1 here. So u to the half times 1 all over 1, which is the same like u to the half plus k. U to the half means square root of u plus k. But in the beginning, we said u was equals to x squared plus 4. That means the square root of x squared plus 4 plus k is the integration of this function. And looking through the options here, it means the right answer is this one, which is C. I have 2 channels in YouTube where I give out free math videos to everyone. Bone math classes and bone math revision. In bone math classes, I teach the theory. In bone math revision, I solve past questions in the GCE. Let's say if you watch a video in bone math revision and you didn't understand the solution, you can come to bone math classes. You will see the topic related to that solution with explained concepts and solved example. To be able to continue seeing your videos, you need to subscribe to the channel and like any video that you see. Subscription is free. To subscribe, you come down to this subscribe icon and you click. When you see subscribe, it means you have already subscribed. And then to like, you come to this thumb icon, you click. Sometimes you may want to subscribe, they ask you to log in. Yes, you need to log in to YouTube using your Gmail. To log in is free and to create a Gmail is free.